My name's Feynman Liang. I'm the Director of Engineering at Gigster. At Gigster, we solve a lot of engineering problems over our 100 software projects. One of the biggest challenges that we face is the ability to standardize across a variety of projects. Oftentimes, developers want to use the tools they're most effective and efficient at, but at the same time, as a company, we need to ensure consistent and reliable delivery. Standardization, on one hand, allows gains across scale, but limits developer productivity. So struggling to find the balance there has been one of the key technical challenges that Gigster's had to face. At Gigster, we're collecting data across hundreds of software engineering projects, all running concurrently. We ingest data from Slack, from Trello, from GitHub, from Gmail, and we aggregate all of that stuff together to provide real-time status updates and predictions about the outcomes of a project. Operating at this scale requires instrumentation of multiple systems in heterogeneous environments. Each system speaks its own language, and a failure in one component can propagate to failures in numerous downstream components. Debugging and diagnosing these distributed systems has a really long iteration speed and is often very non-trivial and requires expertise in numerous technologies. So running such a large stack which processes so much data oftentimes results in a lot of engineering overhead. Some of the projects we're working on right now, we're able to run off of our simple little 4-node Kubernetes cluster. We don't really run into issues about synchronization and concurrency quite yet, but as the business scales up and the data no longer starts fitting on single machines and you need parallelism on multiple parts of the stack, you're going to see these synchronization and locking issues resulting in more problems in your operations. We really like functional programming. Functional programming gives us a lot of ability to reuse. The style of functional decomposition, taking a problem and breaking it down into smaller sub-functions that and having pure functions which do one thing well, and then finally composing that to form your whole solution, is kind of the way that we approach a lot of programming, and it allows you to reuse individual chunks in other parts of your code base. One type of functional programming we really like at Gigster is statically typed polymorphic functional programming languages. Scala is an example of one, Haskell is another. We're seeing this arise in other frameworks such as Flowtype and TypeScript, and we've seen that utilization of these technologies results in developers writing safer code that fails in development rather than production, and overall result in reduced downtime and higher developer productivity. The community, Alexi, the organizer of the conference, and his PhD advisor was my undergraduate advisor. It's amazing coming here and connecting with Alexi again, as well as getting involved with the community that he's built around Scale by the Bay. I get to meet all of these people whose names I see on GitHub and put a face to the name, exchange contact information, and get involved and discover new things that I didn't know about within the Scala community.